Hello, and welcome to another episode of Amiga Retro. Today, before you, behold the glory of not one, but two Commodore VIC-20s. The top model is my personal favorite and the one that I'll probably keep. This one will be basically used as parts and spare parts and whatnot, even though they both fully function, but obviously the one's in a bit better shape than the other, and you'll see the difference when I also take them apart. But anyways, I digress. The top model here is the earlier one. This is a model that was made in Canada, so that's my home country at present. And the bottom one was made in the US. There's slightly different board revisions, and you'll see on the inside there's also drastically different innards as well. So I took the liberty of taking out the screws. So let's get to this. I shall take both of them apart. The top covers will just come off with the keyboard, and then you shall see what lies within. So now that my autofocus has been set to auto, hopefully it works, it can show you one of the big differences between these two computers. Now you notice there's a lot of heatsink material happening here. There isn't really any on this board. That's because this one uses a different power supply. It's AC input only for the power, where this uses the traditional Commodore 64 power supply, which has your plus 5 volts and 9 to 10 volts AC inputs. So basically this 5 volts that goes into this motherboard has already been rectified by, of course, sorry about that, this power supply here with all the specs on the bottom, if I can get it in frame. So it's basically, if I can read that, yeah, it's your usual about 1.2-ish amps, I guess, on the 5 volts, and then 9 amps, or 1 amp on the AC on this one. So this is like the one used in the Commodore 64. So with the older VIC-20s, of course, as part of the cost reduction program, you can use it on the VIC-20 or the Commodore 64. And as you can see, if I can get this into frame, it has the traditional DIN connector that you would see on the Commodore 64. So this will definitely be, you can use the same power supply. So that is the part of the cost reduction method. The original, this is the VIC-20 power supply, which even says VIC-20 right on it. And as you can see, you can actually operate 117 volts. It's kind of weird. Even though it's only for North America, you can do 47 to 63 hertz, which is kind of odd because they almost went where it's interchangeable with the market overseas and Europe and whatnot. But of course, if that's the case, it would have to be 220 volts. So yeah, this would still burst into flames if you tried to use it over there. But it's kind of neat that it can operate in that range. But at least that's the transformer, right? So, but the output is 10 volts AC at 30 volt amps. So basically this is 3 amps output on the AC, and this produces AC only, unlike the other one that's over there, which does the rectification of 5 volts, which is and the AC. And of course, we know the 5 volts in these power supplies have a tendency to go bad and then kill things. So in the case of this computer, it would be the regulator, which I believe is here, the 5 volt regulator. If that went bad, then it would incinerate the various components. And as you can see, one moment, this has a completely different plug. And there you go. So the older board, this one, just AC power supply only. It does all the DC rectification right here, where the one below here, the later models use the same power supply as the Commodore 64. So it's kind of nice. See, I can use that power supply for either. For this one, I better make sure that this stays nice and healthy, but it's not the end of the world. I could find a power transformer if needed at the specs. So we'll see. But anyway, enough of my blabbering. Now we'll get to the main attraction, the parts that I ordered to build a new board for the VIC-20. And here we have it. So from Run Stop Restore, get it? Restore, is where I ordered all the parts, passive, I got everything, all the ICs, everything to build this completely without using any parts from a donor board or anything like that. And I got that from like I said, Run Stop Restore. And this one, the board I ordered from Tindie or Tinde. So it has like a picture of a dog for their logo or something. But this is the board that I ordered, and it's beautiful. It's a beautiful blue color. It's very shiny. And whoops, sorry about that. And yes, it's the Vicky-Twenty, and it even has the assembly number 250-403-1982. So this is a replica of pretty much the original shortboard, I guess, or something along those lines. As you can see, it's a lot smaller than my favorite VIC-20, but it is it'll fit in the same case. Any case I get for the VIC-20, this will fit. So I will assemble this, I guess, and show you step by step what does. So basically starting with the lower profile components like the resistors, and working your way up to the larger components, sockets and integrated circuits and all that fun stuff. And everything actually comes with sockets as well. I'll show you here. I'll put this board aside gently. And this is basically just a bill of materials. It's basically everything that came with the parts that I ordered. There's 2 sheets. This is all the passive components, and then there's other stuff, integrated circuits like your logic circuits, all that fun stuff, and all that. So, and I highlighted in yellow here is anything that requires attention that you may or may not need to install these components depending on the operation. So that will be determined at that time if it actually powers up once I solder all the components. So I'll put that aside. And yeah, it came with the infamous Chicken Lips logo, which you can actually attach to your shirt or lapel or something. So that's kind of cool. It's a bonus. Yep, so this is some run, stop, restore paraphernalia from the retro 8-bit shop as well. And QR code, you can download the app, all that fun stuff. And yeah, this too is the bill of materials that's on both sides. So I didn't even realize that was actually in here. So I downloaded it and printed it myself. So I guess I got a copy, right? Never have too many. So I will set all of this stuff aside. There we go. So here we have all the stuff. So these are all the components. So this is for the power rail, filters, and semiconductors. So it's like ferrite beads. Looks like a voltage regulator. What else do we have here? Yeah. So other parts. Oh, and then the AC bridge, full wave bridge rectifier. So it comes with everything you need. You order these all, and these are all the, like online, these are all the connectors, obviously, for the video, the serial, all that. So the power, it's got the power switch. I don't know how they find these things, because these are very difficult to find, these power switches. And it's kind of nice that it comes with it. It comes with the keyboard header. So those are all your connections. These are all of your sockets. Everything is socketed on here. So CPU, all the logic circuits. Set that aside. Capacitors and resistors, so your passive components. These will be fun as a capacitor and resistor kit. And getting to the bottom here, and that's your RAM and logic kit. So it has your memory modules, which there's not a lot of. I think there's 2 or 3 chips, or 4 or something like that. And yeah, that comes with all the logic as well. And these are the actual chips that are required. So it's going to be kernel ROM, character ROM, CPU, all that fun stuff, and of course, yeah, the VIA chips, which are similar to the VIA. It's just for the control ports, the keyboard, you know, your serial port, all of that stuff. Basically, it's the same idea as the CIA chips on the Commodore 64. And there we go. And that is everything. Put that off to the side, and I guess we shall get started. So as you can see, everything is ready to go. The good thing about it is everything on the circuit board is labeled, so as in a resistor, capacitor, what the actual value is. But if you're not sure, on the bill of materials, it will, close I can get this, it'll even tell you the color banding codes and all that stuff and the value of the component. So that will come in handy to make sure you don't put in the wrong parts, because that could be detrimental to performance or catastrophic depending on what gets installed. So the first thing we'll do is show you how to, well, put in a resistor and solder it on, and then we will go from there. I will be right back. Actually, before we get started, one neat tool I have is this component tester. Now, even though, like I mentioned before, it shows you the banding on these components, like right here, I can zoom in on that, which is brown, black, red, which is a 1K resistor. But what's good about having this, if you are like with me, I need glasses for pretty much everything close up, you can put it into the component tester right here. So between 1 and 2, lock that down, and then have it test the component. And any second now, there we go, 989.6 ohms. So basically, it's a 1K resistor. So I know, without shadow of a doubt, that one, of course, the component works, but also it is the correct value in case I, for some reason, misread this. And if you're colorblind, these tools definitely come in handy. Well, of which I'm not, but I do have a couple of friends that are, and this definitely is, kind of helps. So that being said, I will now install this resistor into this motherboard. And I will be right back. Back indeed. Okay, looks like we're recording. Soldering iron should be up to temperature, at least I'm hoping. Actually, it would be nice if I had the solder ready. Let me get this out of the way. I will use it as reference if needed. And like I said, everything is marked on the silk screen on the board, so I should be okay. Grab some solder here and start doing this, I guess. Try not to get in the way too much of the camera. Clean the solder tip, and then attempt without getting my head won't be anywhere near this, so that's good. And I don't even have the soldering iron on. Isn't that, now it is. That always helps, doesn't it? So it'll take a second for it to come up, and I will be right back. Okay, soldering iron is up to temperature, and let's do our first solder connection. Here we go. Be nice and gentle with it. Dwell time of about 5 seconds. Heat up the pad. Wait. And this solder has flux in it, and it is tin solder, not silver. I don't have luck with silver solder. It requires a higher temperature and more patience than I possibly ever would have. And that's the first one. So before I'm going to cut this off, I'm going to flip the board over. And if I can see what I'm looking at here, there we go. Yep, right here. And it looks good. It actually soldered a bit onto the other, because they're plated on both sides, so some of the solder came out on the other side. And I'll touch that up, and I'll do all the other resistors the same way I showed you, and then I'll be right back when I move on to other components. Okay, that was a bit of an adventure. I'll separate the rest before I install the remainder, but I will show you the process of putting the socket on the board. I'll move this out of the way. And do I have enough zoom on this? That's as much as I'm gonna get. Okay. So this is the socket here, and make sure the notch in the socket, which is right here, lined up with the top of the board. If you install it in backwards, it's not the end of the world, but it might make future installation and removal a bit on the confusing side. So, of course, I bent some of these pins ever so slightly, trying to remove it from the stack. So let me just try to get that in. Let me lift the board up a bit. There we go. So it's orientated in the right way, and so I'm going to flip it over and bend one of these on the kitty corner, if I'm in the right area. There we are. What's happening? The socket has shifted out of the... One moment, please. Let me try this again. I'll do what I normally do. I'll heat up this one here, and then I'll push down on it to make sure it sets flush. there's a bit of movement. And then I'll do the other corner. Same idea, I'll push down on the corner underneath with my finger. And yeah, there's no movement. And I'm looking at the socket itself, and it looks, you can see that if the camera will focus on it, it looks pretty flush. So that is good. I don't see any gaps or tilting. So what I'll do is I'll solder up the rest of the pins, and I'll be right back. Okay, so as you can see, I have successfully, take off my other set of glasses, soldered in the socket. I can get a bit closer view here. Hopefully you can see that, because it's kind of hard for me to see that in the camera, but anyway. So what I'm going to do is I'm going to flip this over, zoom out a bit. I said out, there we go. Yeah. So what I'm going to do is I'm going to solder on all the sockets, the remaining 1, 2, 3, 4, 5, 6, well, a whole bunch. I'm not going to count that, I'll go on for a while. But I will solder the rest of these sockets, and I will join you at that time. Okay, this of course is taking a very long time, like hours, 3 hours, maybe 4 to get to this point. So I have all the sockets installed, all the capacitors are installed. Pretty much all I have left are these ferrite beads to put in the on the board. The various active components, like I said, bridge rectifier, a few coils and whatnot, and of course the card slot connector, and then of course all the switches and ports to be installed. So that won't be too bad. And once I get that finished, we will be pretty much done. I will be right back. So finally, after about 6 hours of laborious labor, the board is complete. All I have to do is populate the sockets with the many integrated circuits I have. So basically some of the custom chips, like VIAs and whatnot, and ROMs, which I believe some of which are in here. So all of those will be installed, and it's good to go. And it took me about a good half an hour to get rid of the flux off the board. The top wasn't so bad because most of the soldering was done underneath. If I can flip this around. So as you can see, the flux has been nicely removed. A bit of glare there, sorry about that. So the board looks just as good as it was before, even with the components on board. So that is good to know. So now what we're going to do is we're going to put the chips on this board. Hello, I have returned. As you can see, I have populated all of the sockets with the appropriate chips. Unfortunately, the 74LS138, there's 3 of them on this board. One of them was missing, so I got 2 instead of the 3 as mentioned in the parts list. As far as I know, that might only be responsible for this card slot, so we can still try it to see at least if we get a basic prompt and all that fun stuff, but unfortunately I can't try any cartridges because I highly doubt this is going to work at all. So I ordered one from eBay. I also luckily had the donor, what you call it, kernel ROM here from the American-made VIC-20, because that did not come in the kit. Apparently you can buy it separately, but it wasn't as an option on the kit from 8-Bit Retro, which I thought was kind of weird, but I didn't notice at the time. So this here has been borrowed from the other VIC-20, and unfortunately the legs on the supplied VIA chip, 2 of them broke off. They were slightly bent when I tried to straighten them out, and I did try gently. They just fell off. And there's a couple more that looks like they're they're hanging by a thread, and they won't even survive being inserted into the socket. So once again, the other VIC-20 came to the rescue, and I was kind of lucky because it had, of course, 2 VIA chips. One of them was actually socketed, so there it is. So that is that, I guess. I did order, like I said, that chip from eBay. and hopefully it will come in eventually so we can do a full test, maybe the next time I'm back, and we'll see if everything works. But we will try to see if we can get at least something on screen with this. But just to recap, I had to supply the kernel ROM because it did not come in the kit. The kit was missing a logic chip, the 74LS138, and it was also missing a filter / surge suppression capacitor at 0.1 microfarad. So I had that. Unfortunately, I did not have the chip. And like I said, luckily, you know, I had a spare VIA chip. I also ordered this from eBay as well. That way I can at least get the other VIC-20 up and running back to the way it was. I don't want to use it solely for parts if unless I absolutely have to. Anyways, enough of the rambling again. I'm going to hook this up to my monitor, and you will see if it powers up. And now it's a moment of truth. Hopefully without that one IC, hopefully it's just for the cartridge port, I should be able to get some kind of output on this monitor. So I have the power hooked up, I have the video hooked up through the RetroTink 2X, and video, yeah, everything seems to be fine. So let us and unlike before off camera, I actually have the power supply plugged in properly. Now I'm using the regular Commodore 64 power supply that this will use, and let's see what happens when I turn this on. Hopefully something besides smoke. Here it goes. Oh, well, that's something. It's not quite what I wanted. I don't know. There's at least an image, so I know the video is working. But apparently, like I said, if I knew that's, not because of that one missing chip, I am not sure. Interesting. Everything else seems fine otherwise. I do get a video output, and it is PAL because it's kind of shifted to that side, because I did order the PAL VIC chip. Now, I was told in the manual that there's a 560 picofarad capacitor. Little guy right here. Oh, there we go. Kind of looks weird with that background. That I might have to put across a resistor on the back of the board if it won't boot. I'm not sure if this is what it meant. I can try it, and then I will get right back, actually. I'll be right back. Right back, I say. If I can find the off switch. Well, as you can see, adding that capacitor to the back of the board, that didn't change anything. So I think that chip is required, because I have swap them around where they are the same chip, and either I get that screen or it's completely blank. And of course it keeps doing this off and on thing. It might be more the monitor than anything else. So I will quickly show you what I'm talking about. I can get the camera more lined up here. Where are we here? There we go. This is a 56 picofarad capacitor. It says on the board it may not be required. It depends on the timing circuit, or the IC, I think the 7402. With or without it, it seems to exhibit the same results, but I'll leave it on there for now. But I guess what I'm going to do is I'm going to see if because being impatient to wait for this other chip, I'm going to try to remove one from the other, the not so great looking VIC-20, I guess, and see if that helps. If not, I don't know, maybe there's something else going on with this board. Yeah, oh well, we'll see what happens. I will be back. So here's the board from the American-made, oops, sorry, I don't want to destroy this thing. VIC-20 that I've been taking parts out of. So the kernel ROM was here that you saw on the new board. And of course the VIA chip that the only one that was socketed, that is also on the new board as well. So the chip I'm going to remove will be, I believe, this one here. I didn't take a look at that. These are labeled a bit weirdly compared to the other one, 138. Yeah, these three are 138s right here. Yeah. So this one, and that one. So I can remove any of these. I'm going to put a socket in its place as well. So when I do get the replacement part, I can at least put it back in there, right? So I will, of course, have to unsolder the shield from this thing, so it looks like it's never been out to be repaired, or at least it's been, I think it has been repaired. I don't know, because there is a socket here, so I don't know, whatever. It doesn't really matter. I have to take it off, right? So let me tend to that, and I will be right back. Hello. I have returned, and success as in I have removed the 74 LS138 from this board. I was going to call it donor board, but it's going to be, you know, when I get the parts repopulated and functional again. And I soldered the connections, removed the flux like usual on the back, so it's good to go. So once I get the part off of eBay, put that in here. Put the VIA chip in here, and I also ordered another kernel. This board should be fully operational. But now, as you can see here, I'll zoom in a bit. I said I will zoom in a bit. It's always fun doing this, isn't it? Oh, sorry. Okay, and I think the most zoom I get out of this is, oh, right there. And this is the chip from the donor board right here, so the 74 LS138. So let's see now if this will boot up, I guess. Initialize, give us a screen of happiness or something. We shall see. Okay, so let me just try to look at this monitor a bit better. The glossy monitor, yes. Okay, so I'm going to power cycle this again. So it is hooked up. We are good to go. And now I shall turn it on. Here goes absolutely nothing. Success. The other time when I had the garbage on the screen, it was black and white. It would have been color. I had the wrong input on the RetroTink 2X because this came up black and white as before. There's a bit of noise distortion in there, but that could be something to do just with the output circuitry, or it needs some fine tuning. I'm not sure. I've tried mucking around with a few settings. There's a variable cap, which seems to do nothing, and a variable resistor, which I think just affects the brightness of the output. But other than that, the weird artifacting you see, I'm not sure how well you can see that on the screen. Can I zoom in more? Yes. There we go. I'm not sure how well that shows up on the camera, but still, it looks fully operational. Like I said, it's the output is not the greatest, but I'm not sure what's going on there. But at least it seems to work, as in at least ready for the command prompt. I can hook up a keyboard to it, I guess, and see what that does. And while I'm at it, I might as well throw in a cartridge as well. 1 second. So as you can see, I have the keyboard attached. Of course, the board's right underneath it. The power LED is functioning, and of course we have a prompt window, so I can type in basic programs and all that fun stuff. Let me try to get a slightly better position for you. Sorry if it's a bit on angle, but I can't do much at the moment. So I'm not sure if that artifacting there is just a cause of the RetroTink. I'm not sure. I've used this before on the other Commodore VIC-20s, and it doesn't quite give that same pattern, but I'll look into that later. So let's see if the keyboard works. Oh, yeah. Oh. Point. Anyway, geez, I forgot how to use this. That's kind of the run, stop, restore. That always works. There, see? Much better. And if you're wondering why it shifted over that, I was told because it's the PAL, so I'm not sure. Once again, unless I hook it up to an actual CRT, I'm not sure exactly how this is supposed to look through all of this upscaling fancy technology. So I'm going to put in a, whatchamacallit, God, I can't speak today, a game cartridge, and we'll see what happens. Okay, so I'm going to put in the Pen Ultimate Plus 2 cartridge, which has a bunch of games, RAM expansion. It's pretty much anything the VIC-20 would ever need from forever on this simple cartridge. Well, simple to use, but probably complex? Whatever. I digress. Anyways, let us install this and see if it runs. And also, this will check full functionality of the computer, including the port. So one moment. Not sure how well this is going to work because there's no actual case here. Okay, I'm going to do this off camera so I don't destroy anything. I'll be right back. Okay, the cartridge is installed. And here goes nothing. Let's see if it functions. I should actually get the joystick. One moment. Since that will also be a good test as well. Okay, I will plug that in without destroying anything. Okay, it's plugged in. Oh, sorry about that. Let me get that closer here. I am now turning on the power. And there we go. So yeah, there seems to be a bit of, like I said, a weird distortion in the text there. I'm not exactly sure what's going on with the output. I've had the other computers hooked up. They don't look quite like that as bad. But let's see if the joystick works. Oh, it does. You can also use the keyboard for this. Let's try games. And I don't know, I probably haven't played any of these for a while. Buck Rogers, Centipede. Oh, audio sounds to be good. Press F1 for options. F3 for 2-player, F1 to start. Loud. Very loud. Sorry about that. Oh, heavens. Well, we know that works. And have I died yet? No, I haven't. But I'm going to. Apparently I have died. And I can get out of that. Back to the main window again. So there, yeah, it seems to work. I'm not sure what to do about the that really weird gasp, excuse me. That really weird anomaly in the output here. As you can see, that very strange, almost like textured look. It almost looks like you're looking through a screen door or something to that effect. Yeah, the other computers don't show that, but other than that, it's clear. So I'm not sure. That's a VIC-20 thing. VIC-20. What am I saying? If that's the VIC chip doing that, or something to do with the circuitry, because I don't know. I know very little about these computers, and I've seen other multicolored anomalies caused by the VIC chip as well, if it's in multicolor mode, which I don't think this is. So I'm not sure why it's doing that, but I guess what I'll do is I'll try a different way to display this and let you know. But other than that, that pretty much wraps up this video. Hopefully, if it's too long, I'll break it up into 2 parts. And or I might edit, quite a bit of it out, because there's a lot of stuff that probably would bore everyone to death. I think it even almost bored me to death as well, so I don't need to subjugate you to that as well. But that's pretty much it. If you like this video, please give a thumbs up. If you're not a subscriber to this channel, please subscribe. And as always, thanks for watching.